Hello, this is Dr. Mears. Today we are going to be learning about Venn diagrams. I love Venn diagrams. It actually leads right into tree diagrams very nicely, but let's take one at a time. So Venn diagram is a type of set diagram. A universal set are those sets that are under consideration. So they're the total set in its entirety. This symbol is a capital U here. Subset, one set may also be an element of another. And here's our little symbol. So let's do an example. Please pause the video and take a minute to write this down. We have set M, x such that 2 is less than or equal to x, which is less than 5, and we're dealing with all integers. Set N, 0 is less than or equal to x. Oops, I forgot to put a little x such that, 0 is less than or equal to x, which is less than x, which is less than or equal to 5. There's no equal to sign underneath. And we're doing all integers as well. And p, x such that -2 is less than or equal to x, which is less than 6, and we're dealing with positive integers. What I like to do before I actually go through and do the questions, I like to write down what the numbers are that I'm talking about. It's easier than going here and figuring it out again. So what do I mean by that? So just on the top here, I'm going to write down what numbers are in set M. So we can do 2, 3, or 4. So these are the numbers that are actually belong to this set. So that's much easier to look at than this. Let's do this one between 0 and 5. So we can do 1, 2, 3, 4, and 5. This doesn't have an equal sign, so you cannot include 0. This one does, so you can include 5. And then the last one here, -2 is less than or equal to x, which is less than 6. Now, here's the trick. These are positive integers. So we can't use that -2. We can only do the positive integers. So we're going to do 1, 2, 3, 4, and 5. Okay, that's it. So let's go see if these are true or false. So what this is saying is N a subset of M. So is one inside the other? Are they both the same, or do they have elements that are the same? So let's look. Set N is 1, 2, 3, 4, 5. Okay, so that's the first one. Set M is 2, 3, 4. So this is going to be false. This would have to have a 1 and a 5, so this is false. So this would have to have a 1 and a 5 in it. Let's look at this one here. Is N a subset of P? So they have to have the same elements. So let's look. N, 1, 2, 3, 4, 5. P, 1, 2, 3, 4, 5. Is that true? Yes, that is true. So this is true. So look to see where they're the same. Okay, the same. All right, let's get on to some more notation. We are getting into intersection. Intersection are the elements that are in both sets at the same time. So this is the symbol. This symbol means and. This is both at the same time. This kind of reminds me when we were doing logic and we had the upside down V. Now it's the upside down U. So let's take an example. So let me show you what a Venn diagram is. This is a Venn diagram. This is my universal set. So everything in this box belongs to my set. Let's do A and let's do B. Now if we were going to shade this Venn diagram in to show A intersects B, and we can also say in A and B, that would just be this center. So visually, the intersection is just that middle part where they overlap. They have to overlap. Okay, so that's intersection. Let's go to union. Flipping your page. Okay. Union is the set of all elements that are either in one or the other or both. And it's with the symbol, it looks like a U. It is a symbolic representation of union. Reminds me of the V when we were doing logic. If we were going to color in our Venn diagram with A and B here, it could be one circle or the other circle or both. So basically your circles are all filled in here. So how we write it, A union B. One or the other or both. Okay? And lastly is the complement. The complement are elements that are not in a certain set. This symbol looks like a little eraser, but it's not. It's like a little apostrophe here, so be careful. So again, here's A, here's B, and here's the union. So if we wanted, let's say, not A, so that's how you would see, you're going to see it written, not A here. And this not reminds me of our logic when we had this symbol, but now it's kind of just a little apostrophe. So where would it look like not A? Well, it can be part of B here. You can't fill the middle in because that's still part of A because this is the A circle. And let's see, where else could we do that's not A? I'm also thinking that it is going to be the outside as well because the outside is not A. So not A is going to be there. You ready? Let's do some examples. All right, flip it over. Please take the time to pause the video and write this down. And we have our example of the first is the universal set. So all of these numbers, 4, 5, 6, 7, 8, 9, 10, are going to be going into our Venn diagram. F, 4, 5, 6, 7, that's going to represent circle F, and G, 6, 7, 8, 9, that's going to represent circle G. When you fill in a Venn diagram, please start from the middle. Please start with what F and G share in common, both F and G. So let's look at F and G. The numbers that they share are 6, so fill 6 in, 7, fill 7 in. And I think that's it. Yep. Now you can put the remaining numbers for F, which are 4 and 5, and the remaining numbers for G, which are 8 and 9. So we got everything in F and G. Let's see if there's any number that's not in F or G. So we have 4, we have 5, we have 6, we have 7, we have 8, we have 9. So 10 is left. So 10 is going to be on the outside. Okay. Let's go through and complete the Venn diagram. We did that, so that's a check. Next, what we have to do is we have to write down these sets. So we have to find the numbers in these sets. So we're going to do equals and a bracket. This is not F, so we have to look. What's not F? So remember, not F is going to be not this circle. So this whole circle, any numbers in there, we cannot put in. So let's see what other numbers there are. 8 is not F, 9 is not F, and 10 is not F. So it's kind of like just how I shaded that diagram with the complement. So our numbers are 8, 9, and 10. Okay. Now, if you're not used to what these symbols mean, you can write a little and up above there. So this is F and not G. So we have to look. It has to be F. So here's the F circle right here, the F circle, but it cannot include G, not G. So 6 and 7 belong to G, so we can't use those. So I'm going to put my little finger over it. So the only numbers that are in F and not G are 4 and 5. So brackets 4 and 5. Okay. This is an and. However, sorry, numbers part 3. This is an and. However, it's F and G, but we have to negate it. We cannot have F and G. So we have to look at the numbers that are not in both. So remember, both are 6 and 7. Okay, so it says F and G cannot have both. Not F and G. Oh, is that better? Not F and G. So not the middle. Let's write that. Not the middle. So let's see what numbers are not the middle. Okay. So we have 4, 5, 8, 9, and 10 are not the middle. So we cannot have 6 or 7. So those numbers. So let's write those down. 4, 5, 8, 9, and 10 are not the middle. So that's what these parentheses tell you. So be careful. Okay. And the last thing for today, let's find the number of elements. Remember, this N in front means number of, so I want to know how many. So the number of elements in not F. Well, we just found that. Here's not F, so there's 1, 2, 3 equals 3. The number of elements in F and not G. So let's look. We did that, F and not G. There's 1, 2. And the number of elements in not F and G, we did that here. So let's just count the number, 1, 2, 3, 4, 5, and there's 5. Please, please, please know the difference whether you're counting the number of elements or you actually have to find the number of elements. So these are different. They have different notations. So just be careful on any type of formative or summative or paper 1 or 2. You're looking and you're actually finding what they're asking for. This has been Venn diagrams and our notation. Please practice and do your DCCs because there's an activity coming up.